Welcome to WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, and I'm your teacher. So welcome to class number 3 of our session. I hope you had a chance to kind of look over the material, and we're still in the getting to a started stage here, I think. So I'm going to take a little extra time on the last lesson before we start lesson 2 today. Okay, so we'll normally go just a little faster than this, but I want to make sure that everyone's comfortable with our setup and understands what you need to do. Okay, so I'm going to talk a little bit about the key questions here for lesson number 1. We can even do a couple of them, but mainly I'm just going to sort of explain what I expect for your key questions. Okay. The main thing is that if you're going to send in the key questions, what I suggest you do is you send in the first key question by itself, okay, as soon as possible. And the reason for that, I know it's kind of convenient. You want to do, say, 5 key questions, so that's a whole unit, and send them in. The difficulty with that is if you get on the wrong track right at the beginning, it's kind of, it can be pretty demoralizing to get your mark back, right? So I think it's in your best interest if you're not, especially if you haven't done these before, just to send in the key question number 1 first. Okay, as a matter of fact, and I'm very flexible about this, you don't even have to send in the whole key question. Okay, I'd appreciate if you put a little note somewhere on your assignment that you're only sending in part of it. But if you just want to see what you got, you can send in the first couple of sub-questions, and that'd be perfectly fine. Now, the way it works, and maybe this could be a little different from what you've experienced before. If you send in your key question, let's say you send in the first key question, and you're not happy with your mark. You thought you should have gotten a better mark. Maybe there was something you didn't quite understand. So what I'm going to do, I'm going to put some feedback on your assignment. Usually I'll put a few extra examples. I might put another sheet behind the feedback form, which just has a few extra little tips and some explanation for you, whatever the issue is. So if you want to improve your mark, you don't have to, but usually if you want to improve your mark, you just redo the questions you had problems with, send them back in with your next assignment, and I'll mark that and I'll change your mark. Okay, so that's the way it works. Okay, so don't worry about sending something in if you're not real, sure. If you get a bad mark and you don't like it, then you can fix it and send it back in and get a better mark. Okay, so that's the way we do it. And the reason for that is I want you to be successful, and I want you to walk away feeling that you really understand the material. Okay, and the way that we figure that out is really just how well you did on the assignments. Okay, so that's a sort of an overview of the key questions. And in terms of neatness and stuff like that, it's just as long as I can read it, I'm usually pretty happy with it. The main issue I'll have is something like if you use a pencil and it's really light. Sometimes by the time it gets to me, it's been photocopied and faxed, and so sometimes it can be hard to read. So that's about the only thing that I really am worried about. All right, I think we're kind of ready to get going here. So this is key question number 1. We're on page 10 of Unit 1, and we're just going to wrap things up because I kind of ran out of time yesterday, and so I kind of had to rush off the air. Now, so the key questions, so for example, question number 1 says, for each of the following equations, state whether the parabola would open up or down. Okay. Now notice that I've underlined the key part of the question, and that's part of the 4-step problem-solving model that I used. Whenever I see a question, the first thing I want to do is understand the question. And that's step 1. Okay, it may seem obvious, but sometimes by underlining the key ideas in the instructions, that'll help us to understand exactly what we're supposed to do. Okay. So in this case, it just wants to know whether the parabola opens up or down. So what are you going to be looking at here? Well, you're going to be looking at the value of a, and specifically you want to know whether a is positive or negative, right? Because if it's positive, it opens up, and if it's negative, it opens down. Okay, and that's about it. So for example, take a look at 1a here. Now there is no a value, so you're going to have to kind of in your mind, or you can write it in and say, well, if there's no one, if there's no a value in front of the bracket, it means that it's a 1. Okay, it can't be 0, because if it was 0, it would mean it's 0 times whatever's in brackets, which is 0. And then we wouldn't have a parabola, we'd have a line. Okay, so that's where you have to kind of see that you know, the style, the convention of math style is that we don't put a 1 there if it's not a if it's a 1. Okay, so now that you know that it's 1, it's a positive 1, so you're just going to say that it opens up. Okay, and that's really all we're looking for in that question. Okay, it doesn't say to sketch it, it just wants to know if it opens up or down. Okay, so let's take a look at E here. Now I will say that E is not the usual way that we would write it. We'd normally write it just like B up above, but in this case they've given us a -1. So we know that A is equal to -1 here. You could write that down if you wanted to. Might help you to understand a little bit. But basically the question asks us, does it open up or down? And in this case, it opens down. Okay. So that's what we're looking for in that question. Not a lot of calculating to do, but just making sure that you understand what the A does. Now, a little more challenging is the question 2, where we want to know what is going to happen with H. It says, for the following equations, state the value of H. Okay, so that's an important thing. I don't think it said, yeah, it didn't say that for question 1. So we want the value of H and describe the shifting of the function. Okay, so we better describe the shifting of the function. Now, in this case, unfortunately, the instructions aren't all that clear, because they want to know H, but then they don't say the shifting of the function due to H. Okay, but you can, I'm going to write that in, due to H. Okay, because otherwise then you might think that you're going to describe what K does and everything, which is, there is a question like that a little later on. So this could be just a little bit clearer. The instructions could have been a little clearer for us. All right, well, let's take a look at one of these questions. Let's pick one that's looking a little tricky. How about question C here? This one looks kind of challenging, and the reason is, actually no, that's not really challenging, because we can figure out what the value of H is by looking at the expression inside the brackets. Okay, and just as a little reminder, then. I'm just going to make a blank page here just so I can do some writing. Remember that if you see x minus and then some number, that means that H is positive. Okay, and the parabola shifts right. Okay, and it's just right by whatever the value of H is. Okay, if you see x plus some number, then we know that H is negative, and the parabola shifts left. Okay, now I'm just gonna make my. Now, the reason for this, and you know, I've tried to explain it, but it's worth repeating. The reason for that, let's say that H is equal to 2, okay, over here, and then over here H is equal to -2. Okay, so let's take a look at what happens when we plug H. If we have a standard form y equals a times x minus h squared plus k. We have that standard form. So over here, we're going to replace a 2 into h. So minus, and I'm going to put the 2 in brackets, squared plus k. And so when we simplify that, we have x negative. All right, let's just go off to the side here. And I have a negative. Remember how this worked, right? We had a negative 1 times 2. The signs are different, so the result's going to be negative, and 1 times 2 is 2. So we end up with negative 2 right here. Okay. Okay. So that shows you then that if our h is, if we see a negative sign in this expression, then that means our h value is positive. All right, so let's see. Who do we have from Kingfisher?
Teresa.
Okay. Okay. Can you say your name again?
Teresa.
Oh, hi, Teresa. How's it going?
Okay.
Okay, great. All right. Do you have all the materials for the class? Do you have Unit 1?
So this is just photocopying it or printing it.
Oh, okay. All right. Well, you can just sort of follow along a little bit here. Now, are you logged into Smart, Bridget?
I'm on it.
Um,
I'm just logging and
Okay. So you know how to do that though, right?
yeah.
Okay, great. So you'll be able to follow along. Okay. So what I'm doing is I'm just going through key question number 1. So it's not too bad because what I do is I put the lessons on YouTube, and so I'll explain how to find them if you want to look at the last couple of lessons.
Yeah.
Okay. Great. All right. Well, glad you could join us here, Teresa. Okay, great. And so what I was just showing there was how we have. Okay, I see Teresa on there now on Smart Bridget. And so this is why if our h is grab my pen. So if our h is positive, then when we plug it into the standard or the vertex form of the parabola, we end up with an x minus whatever the value of h was. And that's this case right here. So our h is positive, and it means that our parabola shifts right by 2 units. Okay. Well, let's take a look at what happens when we have h on this side. When we have, I'm going to erase this a little bit over here. When we have a h negative, okay. So now when I substitute this in a x minus, now we have to substitute in the sign as well for our h because it is a negative value. So when I simplify this, I have x minus negative 2. All right, well, I'm going to go off to the side here in green, and I'm going to say, all right, I have negative minus 2. What does that simplify to be? Well, remember that when we have a negative sign in front of a bracket, what it means is negative 1. Okay, just like if we have nothing in front of a bracket, if it's the first term in a expression or an equation, then it is assumed to be 1, even if there's nothing there. So we have negative times a negative. Well, when the signs are the same, the answer is positive. And then 1 times 2 is 2. Well, of course, we would just normally write that 2. Well, let's go back and substitute our 2 into the bracket here. Actually, let's go substitute our 2 into this whole expression, because that's what we were simplifying. Okay, so now we have x plus 2, because it's a positive value, squared plus k. So notice that we changed the sign inside the brackets by substituting a negative value for h. So that's the second case over here. When you see a plus sign in those brackets, it means that your h is negative, and it means that your parabola shifts left. Okay. All right. That's probably the trickiest concept, I think, in lesson 1 here. So let's go back and take a look at the key questions. So this is page 10 of Unit 1, and we're looking at the key questions. Now, we were looking at specifically at, what were we looking at? Okay, I think C, something like this. So we see that H, in this case, we see the negative sign in there, so we know that H is positive, and so thus it must be 4. Right, H is 4, which means that if I was to sketch this, it doesn't ask you to sketch it, but if I were to sketch it, this is uh, your y equals x squared, so that's the standard parabola. This one has a negative sign, so it will be opens down, and it also shifted down 2 units, but it's shifted over to the right 4 units. So I'm going to change colors there just to make it a little clearer. So this is the one we're looking at right here. Something like that. I mean, we're just going to sketch it. Okay. Okay. So what it's asking us, though, in the question is just to state the value of h. So we stated the value of h, and then describe the shifting of the function. So if I actually wanted to answer the question here, I'd say shift right, shift. Whoa. All right, let me just. Oh. All right. Well, anyway, let's try this again. So h equals 4. And then let's just say right 4. That's it. That's all you have to say for question C right there. Okay. So, all right. So you give those a try then. Okay. Now, for question 3, it says graph y equals x. So that's what I was showing you just above. So what they want is they want you to graph y equals x squared. Now that's always going to be this. Okay, this is your x, this is your y. That's what y equals x squared. It's always going to look like that. And then they want you to graph each of the functions given below. So in this case, we see that for a, 3a, it's y equals x minus 1 squared. So our a value is equal to 1, and our h value looks like it's equal to 1 as well. Okay, so with a equal to 1, it means it opens up. And with h equal to 1, it means it shifts over 1 unit. Okay, so then on your parabola over here, on your little sketch, you would do something like, and I'm just doing this really quickly, so double check. I may have gotten this wrong, but there you go. So that's 1 unit over to the right. Okay, so you'll have to check, but that looks like pretty much what 3a would look like. So notice it says graph. But really, sketch. Okay, that's what I want you to do is just sketch it. Don't waste a lot of time drawing a nice, neat graph. Just sketch it. Okay, unless you like drawing graphs. Okay. So that'll get you through number 3. Now, question 4. I think now now it wants to know the value of k, and of course there we go. We have our values of k right there. And just again, shifting of the function due to k. Okay, so just tell me whether it goes up or down, how many units. Okay. All right. And on to the next one. Okay. All right. All right. So now it wants you to graph these functions here below, and in this case we sort of want to know what it looks like. So let's take a look at question 5a, and so you probably need some graph paper. If you can't find any around, just contact me. I'll be happy to email you a file that you can print out with graph paper. So let's see here. I'm just gonna switch to some graph paper. Okay, there we go. So you don't need really fine graph paper for something like that. We just really want to get an idea of what this function looks like. Okay. So the first thing we need to do is have some values, right? So this is x and this is y equals x squared plus 7. Okay, so we're going to try that. So what I suggest you do, you just want an idea of what the shape of the function is. So try something like -3, -2, -1, 0, 1, 2, 3. Those should be enough values to get an idea of what it looks like. Okay. And I kind of made a mess of my table. So let's take a look here. So we're going to substitute -3 in this equation. So y equals -3 squared plus 7. Okay. Now -3 squared, if you have a squared button on your calculator, you could just use that. Or you just type -3 times -3. And remember that when you're multiplying signed numbers together, if the signs are the same, the answer is positive. And I'll give you a little hint. Every time you square a number, the answer is always going to be positive. So 3 times 3 is 9. 9 plus 7 should be 16. So there's our y value for the first x, 16. Okay. And you don't necessarily have to write out the whole equation, but it can be kind of helpful. For the second one, it's going to be y equals -2 squared plus 7. -2 squared is 4. So 4 plus 7 is 11. Okay, so there's your value there. All right. -1 squared is just -1. 1 plus 7 is 8. So that's going to be 8. 0 squared is just 0 plus 7 is 7. Okay. Now here's where things get interesting, because 1 squared is 1 plus 7 is 8. Okay. 2 squared is 4 plus 7 is 11. And 3 squared is 9 plus 7 is 16. So you notice that I meant to say 11, 16. You'll notice that the second half, these ones are identical to these ones. They just kind of go up in the opposite. And you'll find that that's always the case with a parabola because they're symmetrical. So you can save yourself a little bit of work there if you notice that. All right, well, now that we have our y equals x squared plus 7, now we can put it on our graph here. So this is your x, this is your y. Our biggest value is 16. So let's see, if we go, let's see, 2, 4, 6, 8, that's not going to work. Let's see. All right, let's say 4. If this is 4, 8, 12, 16. I think that works. We go up by 4s. Okay. And so then this would be -4, etc. And then over on the x-axis, we're just going plus or minus 3, so we can just go by 1. Yeah, we can go by 1. -1, -2, -3. I suppose I could have skipped every other line there. And now we'll just make our coordinates. So x for the first one's -3, and y is 16. So our x is -3 over on the left, and it's 16. Okay, so there's the first one. The second one is going to be a -2 and 11. So let's see. It's going to be right around there. Don't stress out too much about it. We're looking for a shape here, not we're not sending this into a mathematical journal. So the second one, -1 and 8. Going to be there. For 0, it's just 0 and 7, so that should be just right around there somewhere. And now again, you notice that you can double check, but notice that it's symmetrical. Okay, now you just join all the points together with a smooth curve, and there you go. That's your parabola, and that is y equals x squared plus 7. Okay. And you also want to put your regular y equals x squared on there. Okay. And now let's see for the, oops, let's see. Actually, it's going to be everything. I'm just going to undo some of those. All right. The nice thing about this one is that the only difference is that we just added 7. So our actual y equals x squared is just going to be here, and then all of these points are just going to be 7 minus whatever they were here. So that was 11 minus 7. I think it's going to be 9 here. I hope I got this right. And then 16. Oops. No, what are they? 12, 11. Oh, so. Didn't mean to do that. You know what? I think I had those right, and then I fixed it. This is sort of a classic error, hey, to do it. Change a right answer. Okay. Anyway, so that's what it's going to look like on our. Oh, okay, I made a mistake. I don't know. So this is y equals x squared, something like that. Okay. I did something wrong. Oh, what did I do wrong here? That's going to go there, and that's going to go there. All right, well, I'll try and fix it a little bit. There we are. That's better. So really all you're showing, this red one is going to be the same for every single question. And in fact, I really I should draw it a little nicer because it actually touches the origin there. Touches this point 0, 0 right here. So that's what question 5A will look like, and then 5B it'll have it'll shift in a different direction, but you'll be able to kind of plot it in there. Okay. So what they're asking you for then is the y equals x squared, which is always going to look the same, and then they're asking you to change it and show the new graph how it shifts. Okay. So the easiest way is just to plot a few points. And you know, here's a few. I plotted a total of 6 points. If you have a calculator, it's pretty quick to crank through them once you get the pattern. You only really have to calculate about 4. Now, some people will not do 3. They'll use something like -5, minus 3, and then 1 and 0. So you can use spaced out numbers if you want. It's perfectly fine. Okay. Just don't put a lot of numbers in there because you'll spend a lot of time doing calculations. Basically, what we want to do is see what happens to it, how it shifts. Okay. All right. So, okay. Now, let's see here. Let's back up a little bit. Open the file. Okay, so that was question 5, and in fact, for question 6, it's similar, but it says describe the transformation. So now we want all of it. You want the A, you want the H, you want the K, and then how it shifts, right? So what I would suggest you do for that is you do A, and then you'd go the A value, the H value, and the K value, and then describe the open, right, and then the shift. You know, this is going to be right or left, and this is going to be shift up or down. Okay. So that's what how I suggest you structure that question 6, just like that. So list all the A, the H, and the K, and just describe the shift. Now, notice that it just says describe it. It doesn't say draw it. So save yourself a little bit of time. Okay. Okay, and now question 7. Question 7 is kind of an interesting question because we didn't really cover this in the course material. Well, sort of. It says the path of a cliff diver as he dives into a lake, a cliff diver. So that's someone, if you think of a cliff, this is a cliff. Okay, and so he's standing out here, okay, and here's where a diagram can really help you, okay. This is the lake down below. I'll make it blue. There you go. There's a lake. Okay. And so he's standing up there, and he's looking down, and he's going to jump. He doesn't just fall off the cliff. He's going to jump up a little bit, you see? Okay. So he's going to jump up a little bit, and then he's going to make a smooth boom. Okay. And he's going to land in the water. Okay, and you'll notice that looks an awful lot like a parabola, right? So, and this is the equation of his fall, whatever. Y equals negative x, um, negative x minus 10 squared plus 75, where y meters is the diver's height. So, let's see. Probably going to look something like this. With, maybe not. Let me back that up a little bit. See, I don't know where the x-axis on here. I'd actually have to work that out. Oh, now I know where the x-axis is. Um, and so there's, maybe that's that's the y-axis. Anyway, so this is his height. Y is equal to his height. But what we want to know is what is his maximum height above the water? Okay. Now you'd be tempted to say, well, maybe this is his maximum height above the water, but the fact is he jumps up, right? Shown by the green parabola. In fact, his maximum height above the water is this point right here, which is the vertex of the parabola. Parabola. Okay, I hope you can read that. That's the vertex of the parabola right there. The vertex of the parabola is either the highest or the lowest point, depending on whether it opens up or down. If it opens down, it's the highest point. If it opens up, it's the lowest point. In this case, we see, because the negative sign in front of the, where A should be, -1 means it opens down, just like I drew here, right? If I actually, I'm missing some of the parabola. I didn't show the whole part of it that's sort of hidden in the cliff, but that's the way the whole parabola looks like. I probably didn't really draw that all that well. So really what they're asking you in this question is, what is the coordinate of that point? I think I've given you pretty much all the information I can. And so what I want you to do is draw a diagram, think about it, and either you got the answer and you'll tell me the answer, or you'll just tell me why you think you don't have the answer. Just describe kind of, what is stopping you from getting the answer. Okay, 4 marks. I want to encourage you to try all the word problems. As I said, I mark word problems based on your engagement with the material. So, I'm not that fussy about, spelling, grammar, stuff like that. Of course, it's important, but it's just really what I want to know is I want you to communicate about the course material. That's where you get your marks. Okay, so that was key question 1, and hopefully you're ready then just to write that out, send it in, and if you send that in, I'll get you some feedback right away. Okay. Now, if I have a way to reach you electronically, like on Facebook or by email, then what I can do is actually send you a scan of your marked assignment. And that usually will get to you probably a good week before it gets to you in the mail. So that's something to keep in mind. If you make sure I have a way to contact you, then you'll get your work back a lot faster. You'll still get the original. Okay, so we're now on to key question. Key question. We're on to lesson 2. Yes. Okay, so that was a fairly lengthy tour through lesson 1, but we had some important things to get just to get clear. Okay, so the rest of it should help you. So lesson 2 is all about polynomials and factoring, and we're going to talk about what a polynomial is and why we factor. Okay, a polynomial is just it's this. Okay, so the polynomial has one or more terms, okay, which can be a constant, such as a 5, can be a variable, such as the x, or it can be an exponent. Okay, but there are some things that are not polynomials. So if it has a negative exponent, it's not a polynomial. And if it's divided by a variable, it's not a polynomial. And the reason for that is that y could be equal to 0. We don't know because a variable, right, it can always be set to 0. So if we have a variable in a division like that, we don't even know if that's a valid mathematical thing to do. If you try to divide 7 by 0 on your calculator, it's going to say something like error or tilt or something because you can't actually divide anything by 0. So that's why we don't want to see variables in the denominator like that, okay, or as part of a division. So anyway, that's a polynomial. So it's just basically polynomial has a constant, possibly a variable, and possibly an exponent. Okay. Now, the other thing is that we have a polynomial expression, which is just a bunch of polynomials that are kind of glued together by addition or subtraction. Okay, that's it. Okay. And you're going to share, you know, we talk about the degree of a polynomial, and the degree of the polynomial is pretty, you know, it's just we look at the highest exponent in the expression, the polynomial expression, and that's the degree. So in this case, this is a polynomial expression of degree 2. Now notice that we sort them, we order our expressions in the polynomial expression. We put each polynomial in order of the exponent. So we have the squared, the x to the exponent 2 first, then we have 4x, and in case you're wondering, of course, we don't write the 1, but it's actually to the exponent 1 right there. And then we put any constant at the very end. Okay, so we order them in order of the exponents. Okay, now if you have a polynomial expression that has more than one variable, because you can have, like you could have 7 x squared plus 6 y squared. You could have something like that. And the way we order those is in alphabetical order. That's just again, that's a convention of mathematics. If I notice that you don't do that in some of your key questions, I'll just point it out to you. I'm not going to take marks off for that, but I will point it out to you. Okay, so try to keep that in mind as you're writing these out. So sometimes when you get to the end and you have everything done in a question, sometimes you have to go back and kind of rearrange things to put them in a sort of a standard order. Okay. Okay, so now we know what a polynomial expression is, and this right here, this polynomial expression, is a different way of writing the equation of a parabola, right? So in other words, if I did a y equals 7x squared minus 4x plus 2, that's actually a parabola, but it's in a different format than the vertex form that we've been looking at. Okay. All right. So let's take a look at probably the middle of page 13, and it says expanding using the distributive law. Now, if you're here if you were in the first lesson, then you actually got an advanced look at this. And if you weren't in the first lesson, I suggest you go onto YouTube and you find it. It's PWWASA. Okay, so it's the same as my Facebook, and this is on YouTube. YouTube? Yeah. Yeah, YouTube. Okay, so this is my my account, and then you can look for MBF3C. I think if you look for 2A and MBF3C, and then each video that I post also has the date on it. Okay, so you'll be able to find the first one on there. Okay, this is actually, let me try to, ooh. Okay, I gotta make this clearer because I wrote it too close together. It's two separate things. It's 2A space MBF3C. So if you look for that, you'll find it. Now the other way to find the videos is to go on to the NNEC website, click on WASA Distance Education, and then go into the class archive. The instructions for that are at the very end of the study guide I gave you. Okay, so it's just a different way of looking at it. Anyway, I'm still going to go through the distributive law. Now, this distributive law is simply, if we have a something, right, any kind of polynomial sitting in front of a bracketed expression, then we want to be able to expand that. We want to be able to multiply, because this is what this means. The 3 sitting in front of x minus 4 means 3 times x minus 4. Okay, so we need a way to expand that, because sometimes as we're working with polynomials and polynomial expressions, equations, we have to have everything expanded out. Okay, and then there's the opposite of doing that, which is to factor things out. So what we do here, if you've ever heard of FOIL, you may remember FOIL from high school, grade school, elementary school, but if not, don't worry about it. But we're only doing the first 2 terms here. No, we're doing the first and the last, I think, for this, because FOIL is for when we're doing 2 bracket expressions, right? 2 binomials. Right now we're doing a single variable or constant times a what's called a binomial, which is just a fancy way of saying 2 things inside a set of brackets. So what we're going to do then is we're going to go the front. Okay, that's the first one. Here, I'm going to, okay, so that's 1 and that's 2. So we're going to do the front, and so it's 3 times x. So that's right, it's just 3 times x, and we can just write it like that. A lot of people will just immediately write it as 3x. Okay. Now, here's where things get a little tricky, because remember that the expression that we're multiplying includes the sign in front of it. Now, we got away with it with the x because it's a positive value. But for the second one, the -4, we need to take care of the sign first. So remember that if this doesn't say anything, it means it's positive. So what we have here is +3 times -4. Okay, now if the signs, if they're the same, then the result is positive, and if they're different, then the result is negative. That's when we're multiplying signed anything together, signed numbers, signed variables, anything. Okay, so if you're not sure about this, just maybe write this little chart down. You can write it much neater than I am. If the signs are the same, then the result is positive, and if the signs are different, the result's negative. Well, what do we have here? I have a +3 times a -4. The signs are different. It means our answer is going to be negative. So I'm going to write negative. Now I've taken care of the sign. Don't have to worry about it anymore. Now I'm just going to look at the stuff we're multiplying. 3 times 4. 3 times 4 is 12. Right? So it's -12, and they've kind of written it down here. Okay. So that was step 2. Okay. So if you do it in that order, then you're always going to get the right answer. All right. Let's see what we have on the next page. So this page 14, I think. Yeah, page 14 right at the top. So here's example 2. Now they've made things, a little trickier for us, because now we have a variable and a constant, but we can still do it. Okay, so you can follow the solution down below. I'm just going to do it over here. So I have 2y times 3y plus 2. Okay. Now you may wonder why we're not using x's, and the reason is we can use any variable we want. Very often, if we're doing parabolas, we'll use x and y. But in business, in manufacturing, and in science, we use all sorts of different variables. Okay, and so they're just trying to get you used to the idea of not always using x. So anyway, we have 2y times 3y plus 2. So let's first of all, I'm going to just moving it over a little bit. Okay, and so what do we have here? Well, I'm going to take the 2y, and I'm going to do the f part, which is the front. And notice I have, this is positive and this is positive. The signs are the same. The answer is going to be positive. So I don't have to write that down because it's the first expression in the sentence. I mean, I could, but it doesn't really, it's not the conventional way of doing it. So now we're going to multiply the variables times the variables and the constant times the constant. Well, what's y times y? Well, that's y squared. Okay. Anything times anything is just that thing squared. If it was a number, we'd be able to work out what it is, but it's not a number, so we're just going to call it y squared. And then we have 2 times 3. Well, 2 times 3 is 6. Okay. And that's it. We've taken care of that first multiplication. Okay. Now, step 2 is to multiply the second term in the binomial by the number in front, or the expression out front. So 2y times 2. First, let's take care of the signs. We have a positive times a positive. The answer is going to be positive because the signs are the same. Okay? The signs are the same, the answer is positive. Now we don't have to worry about it anymore. All right, well, let's try. Let's multiply the constants by the constant. There's 2 times 2 gives us 4. And there is no y in this expression. So what we do there is we just bring the variable along for the ride. Okay? That's it. So there's nothing to multiply it by, but we just bring the variable along for the ride. So now we're done. There's really nothing else to do. It's already in sorted order. It's got the y squared, and then it has the y, and there's nothing else to do here. Okay. So at this point, then, you could go on to the support questions, and you could try these. You see, you can try some of those. You can look in the back at the end of chapter Unit 1. Your handout, there's the answers to these. And I'll just remind you that usually the answers are right, but sometimes they're not. So if you find one that's not right, bring it up. Don't get too worried if one you just can't you check it and it just doesn't seem to work. Okay, try some other ones and it should be all right. Okay. But let's try one of these. So this is 1b here, so it's 5x. Now I'm just going to I'm just going to make a blank page. You can still look at your handout here. So this is support question 1, sub question B. I think that's the one so it's 5x times negative 3x minus 7. Okay. Now that's a good one. I'm gonna change to red. So we have our 5x, and the first thing we're gonna do is multiply that by negative 3x. So the first step then is to look at the signs. Remember, that's going to be positive. So I have a positive 5x times negative 3x. Positive times a negative. Signs are different. Our answer is going to be negative. Now we don't have to worry about the sign anymore. So let's multiply the constants together. What's 5 times 3? 15. Got it. And then what's x times x? Well, that's x squared. Okay, we're done that first multiplication. Sorry about that. All right. And now we're going to take a look at the second. I'm just going to change to green here. So we still have this first one here. And the green part, the negative 7, get used to kind of looking at that sign in front of the polynomial. Okay. So we have, we do our steps, which is to look at the signs. We have a positive times a negative. The signs are different. Negative. And now we're going to multiply the constants together. So 5 times 7, that should be 35. And now we have x, and there is no x over here, so the x just comes along for the ride. Okay. All right, and we're done there. There's nothing else to do. So negative 15x times negative 35x. Now let's take a look at the back here. This is at the back of the. Okay, and we're going to just look at the answers to the support questions and see if we can find that answer there somewhere. Okay, that's lesson 2, so we got to go back just a little more. There's lesson 1. Okay. And actually, no, we're in lesson 2. And there we go. And what did we pick? We picked B, right? We were doing question 1B. And there it is. There's our answer. Negative 15x minus 35x. So That looks pretty good. And what I kind of like about this is that they gave you the steps, the intermediate steps. Now you notice I don't do that, but that's why I showed two different ways of solving it, right? I show my way and then I show the way that they have it in the course text. You can do either one of those if you want. And so negative 15x squared minus 35x. Okay. All right. So just as a reminder then, I suggest you do some of those support questions. Maybe do half of them. Check, make sure that you're getting the answers. You could do all of them. And then you'll be ready to do the key question, which corresponds to that. Okay, you don't send in the support questions, you just send in the key questions. Now, we're just going to get started on this, and we really don't have time to really talk about this, but the second part of this using the distributive property is indeed what we call FOIL. Okay. And what FOIL is just a little memory aid in mnemonic to help us remember how we multiply a binomial, which is two polynomials in brackets, times another binomial. And we do that all the time in algebra. We do that all the time in grade 11. And it's a very, very common kind of thing. And you're going to be using that quite a bit. So the way FOIL works is that, here I'm just going to move this. This is 2x. And we'll pick this up tomorrow. So consider this to be a preview of what you're going to see tomorrow. Okay. So the way we do it is we multiply f is the front. Okay. So we're going to do that one first. Okay. So if I was doing this, it'd be 2x times x, which is 2x squared. And then O is for outside. So we're going to do, whoops, whoa. Sorry. So outside is, we're going to go outside, okay? So 2x times negative 3, negative 2 times 3 is 6, and the x comes along. So that's part 2, okay? And then I for inside, plus 4 times x, plus 4x, that's 3. Sorry, inside. I'm running out of colors here. That's 3. And then 4 is last. We're going to do the last two. So plus 4 minus 3. So positive times a negative signs are different. Answer is negative. 4 times 3 is 12. And now what we're left with is something that's almost a polynomial in standard form, a parabola in standard form. But we have to do one more thing to it to make it correct, because we have two x terms. So I'm going to sign off now and let you think about that. We'll pick this up again tomorrow, and I'll certainly go over this one more time